And we do have such a narrower answer. And it's actually a variant on the there is no answer. So you get back your question. The question section is what you asked. You still get back an empty answer section. What's in the additional doesn't matter. So let's call it empty. But what you get back is an error code that says there was no error, which is bizarre. It's kind of, there is no error. The answer section is empty because for that query type, there is no data that I can provide you, no resource record set that matches your query type.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time, I'm talking to Geoff Huston from APNIC Labs again, in his regular monthly spot on Ping. Geoff and I discussed the slightly complicated way the DNS has to say no. Normally, we all like to think of this as a simple and straightforward answer to a question. But because the way DNS has been used over time has changed to include complexities in answers to simple questions, saying no in the DNS has become just as complicated. Partly, this is because when you ask a question in the DNS, you actually ask two things. Firstly, does the label exist? And secondly, does it have a resource record that matches the type you ask for? The problem here is that you sometimes need to be told the label doesn't exist, and sometimes you have to be told the resource type you asked for doesn't exist. But that leaves open the question, does the label exist, but with other resources? Now add into the mix the complexities of DNSSEC, which has to do something we call authenticated non-existence, which is also called authenticated denial of existence. The way this works, as Geoff explains, introduces a risk that other information about what does exist leaks out into the world, and DNSSEC has had to add additional complexity to minimize harms in this sense, which makes denying things, saying no, even more complicated when you sign it. At a recent DNS OARC meeting, this topic was exercised, along with proposals to standardize how to say no using DNSSEC. Geoff thinks this may be overdoing the standards process. There's a more pragmatic approach which has been explored outside of standards by Cloudflare. Geoff, welcome back to Ping. What shall we talk about today?
Why, thank you, George. I went to the OARC meeting in early February. That's the group that actually does operations and research into the DNS.
Where was it held this time?
This time it was in Atlanta, which is normally quite an exciting and vibrant city, except in this post-COVID age, with all the worker bees appear to have gone home. Downtown city centre is definitely a weird dystopian kind of world with no humans in it. And rush hour occurs on the freeways around downtown, not in downtown.
How things have changed.
I actually wanted to reflect upon one particularly interesting presentation that I think has a number of lessons for us. And that's the concept of no.
Yes.
No.
Oh, all right.
No. The DNS is kind of there to answer your question. Tell me what's www.apnic.net. Give me its IP address. And when you ask that in the question section of the protocol, the packet you get back from your recursive resolve or whatever, in a separate section, you get back your question again, just to know it was, this is an answer to that question. There's an answer section, and the answer says, hi, you want this IP address. Bong, done. And that's all good. But what if I wanted www.apnoc.net or some other name that does not exist?
You need to get back a valid message. It needs to be a well-formed DNS message, but the message has to say the thing you asked doesn't exist.
So in standard DNS, where you've got these three sections in a response, you've got the question you asked, the answer, and you've got an additional section as well, 3 sections.
It's called additional, which I think is the great name for a section. The other bit.
Creative people, yes. And the answer section was called the answer section. It's kind of obvious, really, if you think about it. Look, there was another part too, which was the response code, which is actually part of the header. And that kind of says, this is how you should treat this response. And so what normally happens if you ask for a name that exists and there is an answer for the query type you've asked, it says, hi, this is the answer. There is an answer record and there is no error with my answer. It's a good answer. And there might even be some additional data as well, depending on, the name and what you asked. But if there's no name, it actually gives back a different response code. And that response code is very simply, we call it NX domain. There is no such domain. So the answer section is now empty. It's kind of, yeah, but no. So there is no answer to your question because it's not a name that exists.
Now, that's a very specific kind of meaning to me, Geoff. I mean, I don't want to get all lawyer and legalistic, but we have to be quite careful here when we talk about things in the DNS because it's this distributed system and it has intermediaries and it also has the idea of a zone that's published by somebody, and being told the thing you asked does not exist probably has a really narrow defined meaning here. It shouldn't be anyone along the path chose to say, no, you can't have that. It really should mean the guy who publishes the zone has said to all the intermediate systems, that thing you asked doesn't exist.
Well, I actually think it's quite a broad answer. And it actually over-answers. Because let's say, because you've got to ask for a query type, a resource record. So you've got to say, what's the IPv4 address of, a domain name? What's the IPv6 address of? What's the attribute? And you've got to name what you want of this name. Tell me the answer.
There is the magic question, any, but we've kind of inculcated we're really not going to support using any if we can avoid it because any is just a nightmare. So you ask...
Children, any is a denial of service attack. Do not use it or someone will have to come round to your house and chop off your fingers. It's a naughty query.
So we no longer say, tell me anything you know about this label I projected. You ask a specific question.
And so the NX domain answer is actually overkill because it says this query type that you've asked for and any other query type that you might like to have dreamt up, the answer is going to be the same. No. Okay. So it's kind of an embracing answer rather than you asked for an A record for this domain name. There is no such thing as an A record. And the reason why I make this very subtle distinction is that sometimes you ask for things where the name exists, but the query type you're asking does not. There's a new resource record out there now called HTTPS, not to be confused with the protocol.
It's the name of a field in DNS that can be a type of record bound to a name.
Yes, so you can ask for not the A record, not the quite A record, but you can ask for the HTTPS record. And there aren't that many of them around. So how do you communicate back, nice try, but what you've asked for doesn't exist? What you've asked for, which is different to the name doesn't exist. It's kind of going, I actually don't care if the name exists or not. That doesn't matter. What you've asked for doesn't exist.
Well, the problem here is you just said earlier, the answer is a bit too maximal. And if you ask for a thing that doesn't exist, you get told nothing exists. And you've just unpacked. But if the specific thing that you want doesn't exist, you need a way to refine it down to saying that specific thing. Other things might exist. What do I know? I'm not in charge here. Well, I am. But you know what I mean? We need a narrower answer.
And we do have such a narrower answer. And it's actually a variant on the there is no answer. So you get back your question. The question section is what you asked. You still get back an empty answer section. What's in the additional doesn't matter. So let's call it empty. But what you get back is an error code that says there was no error, which is bizarre. It's kind of, there is no error. The answer section is empty because for that query type, there is no data that I can provide you. No resource record set that matches your query type.
I got an answer, but the answer had nothing in it, and I'm not being told nothing exists. I'm simply getting back empty.
Empty. There's nothing here. That doesn't mean there are or are not other records. And in fact, it doesn't even mean that the name doesn't exist or does. It just simply says, I can't answer your query.
We now have the maximal answer. The label, no matter what type you ask for, doesn't exist. And we have the intensely narrow answer. That specific question you asked I'm not giving you an answer, but I am not telling you the label doesn't exist, and I'm not telling you it does exist, and I'm not telling you any other record type exists. Just the one you asked for, silence.
Right. It's kind of the minimal answer. It's the literal thing. You asked me a question. There is no answer to your question. Okay, so let's park that thought and turn on to the one thing that made the DNS as we know it today, and that's DNS security, DNSSEC. Now, the original model was kind of interesting, and the reason why I go here is that the changes to the model that came afterwards are kind of what we're going to talk about in the end. But let's look at the original model. Now, it was thought that what you wanted to do was to compute a new version of the zone you're serving and in advance add signatures to all of the records for which you were authoritative.
So do all the work up front, create all of the signed state, probably in a belief that that process was heavyweight and costly and you wouldn't be doing it randomly, and that then is the state of the zone, and you can put it out into the world and people use that to give answers.
And you don't need to tell anyone your zone signing key, the private part of that key. You do the zone signing in the back room, wherever you want to do it, and you never leak out the keys. You compute the signature answers and you attach these signatures to the records in the zone, right? So you now say, here's an answer, example.com. It has, for example, if you ask for its IPv4 address, here's its IPv4 address. Oh, and here's the signature of example.com's A record. Wonderful. You can authenticate that signature. You can prove to yourself that's a genuine answer. Life is fine.
As long as you're asking for the A record, life is fine.
Well, if you ask for the quad A, you expect an answer that says, here's the quad A answer and here's the signature of the quad A answer, because every resource record type has its own signature. And of course, you can then validate that signature. You can do what you want. The response is slightly bigger. It adds the signature, which is a hash value, but it's not exactly, huge. It's just a minor increase. But let's talk about what do you do for names or query type names that do not exist. Well, the thing is, this is not, do you remember the QI program on BBC TV? Dear listener, it's the BBC. The non-English folk around the world might not know what I'm talking about. But part of this game, and it is a very, very neat little game, is that the gnomes in the back room try desperately hard to think about the wrong answers you might present. And if you present an answer that is wrong and we knew you were going to say it, big klaxon rings, whoop, 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 whoop. Gotcha. So if I'm going to sign things in advance, then how do I answer for a name that doesn't exist? Now, if I'm a QI gnome, I think of all the possible names you could ask, and oddly enough, I add them into the zone file with a signature that says, nope, try again.
Well, that sounds like a lot of work for an infinity of potential record types and labels, Geoff. I mean, this could expand the amount of work massively.
Easier to say than do. Absolutely. It is impossible in the real world. You just can't do that. So you can't compute a signed answer based on a question that you didn't know in advance. You can't compute the signature in advance. So how do you send back a signed answer that says that name is really not there, or that particular resource record matching your query type really isn't there? It's not there.
So we could call this authenticated non-existence.
Well, that's because you don't want someone in the middle taking a perfectly good answer and substituting no. That's an attack.
Yeah.
You want to sign your no's to say to the other end, it's no coming from the source. It's an authenticatable, genuine no. Now go away.
Now, you've just said not really practical to compute all the potential negatives for a large space of potentially negative things in advance. Doesn't scale, infeasible. So there's got to be another approach to doing this.
And so you come up with the classical DNSSEC approach. Again, I don't want my front-end answerers being given a key. I don't want them to do signing on the fly. So they came across a very, very clever idea of spanning records for that name does not exist. And there's a special record added to the zone file. Now, the procedure is easy to state. you pull up all the labels in a zone, ant, beetle, cat, dog, elephant, order them in a standard alphabetical ordering or, canonical order. And then you create a very special record and you attach it to each one saying the next record in the zone is, and then you say it. So you attach to ant, the next record in the zone is called beetle. And you attach to beetle, the next record in the zone is called cat. And you actually create a new record that bridges the gaps and you sign it. Because you compute it in advance, you can sign that record. That's a clever kind of record.
Right, but I'm trying to understand how this works in practice. So here you've got ant and beetle, and I ask for not aardvark, something that comes between ant and beetle.
Anthony.
Antechinus. I ask for antechinus. What are you going to give me back?
I'm going to give you back the spanning record that says, signed by the zone author, there are no records between ant and beetle. Now, I don't care what you asked for, antechinus, Anthony, antelope, whatever. If it falls between ant and beetle, the answer's no. And here's the pre-computed answer with its attached signature.
Right. I actually really like this, Geoff. This seems to me like it's unimpeachably able to say the authority who can declare what does or does not exist tells you that doesn't exist. But, Geoff, I can see a problem in this right away.
Well, no, let's park some problems here and then just go to a few more sort of clever things. Well, what about when the label's there, but the query type is not defined? I've asked for HTTPS for ant. There is no HTTPS.
Right, which is different to being in a gap between the label ant and the label beetle. It's ant exists, but the type you asked for isn't there.
And again, I can't compute that in advance. But what I can compute in advance is that in this same magic spanning record, I actually enumerate all of the types, the query types that do exist, all of the resource records. So let's say if ant has an A record, now it's signed, so it'll have an RSIG record, a resource record signature. And of course, it has one of these magic records, an NSEC record. So I add a bit mask that says this label has these three records and only these three signed by me. If you've asked for something else, I'm going to send you back that same answer and go, tough luck. I've just proved that that particular resource record type is not in this zone file.
Okay, but it comes back to the same problem that I was going to raise with the first method. I learned additional information, which absolutely is useful, but nonetheless, I have learned extra because not only did I learn there is no record of type foo for ant, I learned the list of types there are. And not only when I asked for antelope did I learn antelope doesn't exist, I learned that what does exist is ant on one side and beetle on the other. And that sounds to me like I could ask a lot of questions and find all the things that exist in the zone and all the types.
Interesting. You see, if you analyze the business of selling domain names, the domain names you actually sell are names that don't exist. Because once they exist, you can't sell them again because someone owns it, right?
When you've sold them, they exist, but until you've sold them, you can sell them, and that means that's where your money's coming from.
That's right. So if I knew all the names that didn't exist in your zone, then I could probably monetize that in some devious way. And so this issue that these magic records, the so-called NSEC records, trivially allow you to actually enumerate the zone, list all the names that exist in a zone. Now, for some zones, the answer is, go for it. I don't care.
Yeah.
But for folk who really worry about this stuff, like the folk who operate .com or .net, and there are a number of others which are important zones in that area, enumeration is a nightmare because their business is in selling the names that aren't there, and being able to find out all those names actually is quite important. So is there a way of stopping that? Ooh.
Is there?
Yes, there is. And it's rather bizarre. So at this point, hopefully your brain is still in one piece because this one is not that hard. You take all the names, don't care about the order yet, and you put them through what we call a hashing function. A hashing function is kind of a bizarre one-way function where it takes a value and produces a different one. And once you get the different value, it's very, very hard to understand the original one. Now, the simplest hashing function around is to transform every input to the output 5. So I just tell you 5. But the problem is that it's kind of not very useful because 5 doesn't tell you much. But if you have a big enough hash space, you can sort of transform a label to a new value, right, in such a way that all the different labels have different hashing functions. But once I tell you it's hashed function, you can't tell what the original label was. You just can't. One-way hashing function.
Right.
So let's say I take all the labels and hash them, turn them into weird strings that really have no meaning. And then I order them lexicographically. I just order them because it's all just, ASCII. And I send you back the spanning record that says the hash of the name that you asked for falls in the range of the hash of a label that does exist and the next hash of a label that exists in order.
But your label didn't exist.
But now you actually can't enumerate the zone.
Right. So I can be told the same technique as in the first one, you don't exist, and the proof is I signed the thing before you and the thing after you, and now you're being told you don't exist, and the proof is do your hash. I'm giving you the signed hashes either side of you that minimally say you don't exist and I signed them. You aren't in the middle, signed me, but I don't know what the labels are, but I do know my hash lies in between them because I can see lexicographically the ones you signed and me in the middle. So it proves you've proved I'm not there.
Yes. And I've made it almost impossible to enumerate the zone. Now, when I say almost impossible, I'm lying my head off.
You would never do that.
Slightly more difficult than trivial is indeed the way things work with today's computing.
Sufficiently expensive that anyone who wanted to do this probably would find it cheaper to do other things.
No, with a graphics card, it's sufficiently cheap that you just aim your graphics processor at it and answers come flying out. It's not difficult. And, do a search on the net and you'll find 10 different ways to undo hashes. And so oddly enough, this idea that NSEC3 records, a so-called hashing function, protects your zone from enumeration, is a bit like the emperor's wearing no clothes. I'm like,
Right. But we've probably kind of dived off the main path here because the point is you'd said there's a way that if you ask for a thing that doesn't exist by type, I can answer for you that doesn't exist, but these are the types of things that do exist. And that is a smaller leak, which is beneficial.
Well, we're going to park that thought and come back to it because it's going to be...
Oh, another park. Are we too deep now?
Yes, sorry. We're stacking them up. Thirdly, that record that says that name doesn't exist, that you're pre-computed, is actually big because now I've got to give you the authority record and its signature. I've got to give you the NSEC of the authority record and its signature to prove that there's no wildcard in the zone. So that's 2 records and 2 signatures, and then give you the NSEC record and its signature. So no is now 4 records and 3 signatures.
Yeah, this is starting to be a huge...
That's big. If you're using RSA 2048, that's not UDP anymore. That's a huge answer. Now, last problem, my zone, Potteroo.net, has a phenomenal 200 entries. I can slam through a signing process in a few seconds. Even with, a machine that's a few years old, it doesn't take long. But let's say Potteroo.net hits the big time. I've sold 100 million names in my zone because, everyone wants one.
Right.
It's just flavor of the day. And I want to sign it. And I'm going to make changes to the zone every day. I'm going to publish a new zone. So I've got 100 million signatures I have to generate every 24 hours.
This is getting extremely expensive, Geoff.
Every 86,000 seconds, I need to generate 100 million signatures. That's a lot of machinery because I've got to, generate a few hundred signatures a second, every second, continuously. So there's a whole idea of pre-compute the zone, compute the signatures in advance, hand it all out to the secondary name servers, the authoritative name servers, and then go, work on this until I send you an update. Kind of doesn't scale. And the thing is, the DNS has to sort of accommodate everyone. It can't just work for little people and not big people. It's got to work for everybody.
We need consistent mechanisms that work at both ends of the scaling system. They have to be amenable to giant domains and tiny domains.
Right. And so it's time to rethink. Now, this rethinking, and this is the critical bit, was done by Cloudflare, not the IETF, not the standards people. It was done by a domain name operator. Once you start down that track of not being the standards people, one of the things you can't do is change the spec. I can't change RFC, 4033 or whatever it was, 4470 or 4471. I can't change the way everyone else works. So I'm now in a highly constrained area of how to be creative, but still be compliant to the relevant standards.
Well, you kind of get to this thing that a bad actor who's big enough can actually force the market and say, yeah, that thing the standard says I don't do that, you have to do this. And if they bring enough people with them at great pain and cost, you can do that. But that's not good behavior. The good behavior would be, don't do that.
No, I've got to be good. I can't push things that aren't in the spec, but I can be clever. I can be very clever. How do I make the answer shorter? How do I make it easier to work with? And one of the things that certainly happened over the last few years is that, machines are better, bigger, faster. And so you can actually consider what we call signing on the fly.
So this is not like the previous case where I, the zone holder, do have a whole bunch of stuff on my central machine and ship it out to dumb devices to feed to the world. This is moving to saying, when you need to have a signed thing, I'm going to arrange for it to be signed then and there.
I unlock my zone signing key from the back office and give that key, the private key, to everyone who is an authoritative server for my zone and say, look, take this unsigned zone. Gee, thanks. And every time you generate an answer, sign it then and there, almost as an afterthought. Just sign it, which is actually really good because if you think about some of these ultra large zones, a tiny percentage of the entries get hammered and everything else gets ignored. But you're spending a huge amount of time generating signatures every day, every second, that'll never get asked for. It's kind of, at what point does that sound crazy? Whereas if I generate it on the fly, for when you ask me a question, I'll generate an answer, that kind of works. I'm generating it only on the basis of you needed an answer, I've given you a signed one. Aren't I good?
Lot to like in this, lot to love. Very efficient, possibly could cache these signed answers, doesn't even wind up being a big burden, nice and quick. I've had to radically alter my security profile here. Those secret keys, well, I just shared the secret with someone I have a relationship with, all well and good.
I can live with that.
Yeah, it's still making me feel a bit tingly, but if we can live with that.
No, I can live.
Okay, well and good.
So the next issue, all of those parties who are serving authoritative answers need to know the entirety of the zone to correctly compute those negative spanning records, whether it's NSEC3 or NSEC. If I'm doing this on the fly, then you need the zone. But if you're a big hosting company like Cloudflare, then that's not a trivial ask. It's a big ask. So the next question, which is really quite clever, is can I do this by tailoring an answer that looks like an NSEC record, but in actual fact conveys a lot less information? It actually says the name you asked for does not exist, and here's a spanning record that says so, but it's not a real spanning record.
Whoa. So you're going to make up some information to create the span that you're going to use to declare, here's the signed proof you don't exist because the two things either side I've signed over, but you're not actually going to have to know the two things. You're just going to make them up on the fly.
Well, you see, if you think about that NSEC record, it actually doesn't say that the two names that are either side of the span actually exist in the zone. That's not what they're saying. They're saying that the label you asked for that falls inside this span does not exist.
And I can prove it because I signed over two labels either side of it, but the existence of those two labels, that wasn't your question.
The label values didn't matter. The whole thing was they spanned the name you're asking for. What really mattered was the signature, because you weren't being asked to prove that those two names at either end actually existed. You're being asked to provide an answer that said the name you asked for doesn't exist. With me? So I've got this signer.
I really like this, Geoff. I mean, nobody's broken a spec here. It still returns a packet that conforms to the shape of a spanned assertion. The thing in between doesn't exist, and it's incredibly lightweight. I had to share the keys, but there's a trust issue there. That's a separate problem. I think this sounds pretty good, but there is this problem. It's not a standard. They just did it.
No, it is a standard because it doesn't break the existing standards. And any resolver that gets this answer, as long as it accepts it for precisely what it is, what I asked for does not exist. But you gave me gratuitous information that I didn't really ask for. Don't count on it, bud. That name doesn't exist. That's all I'm telling you.
Right.
So what you do is you take the query name and you take the name 1 byte before it in lexical order and the name 1 byte after it in lexical order. So it's a minimally spanning record that basically spans that name. And it doesn't even matter if either of those names existed in the zone or not. That's not the point. Here's the span.
Yeah, it's immaterial. It's to prove the thing between doesn't exist. It's not for any other purpose.
And because I'm doing a dynamic signer, I can create this customized record that says the minimal span of the name that you asked for does not exist. Tough. Now, that's half your problem. But the other half is still the SOA record, the signature of the SOA, the NSEC record of the SOA, the signature record of that NSEC record, then this synthetic NSEC record and its signature.
5 things.
Oh, the name doesn't exist. I'm like, call out the people with shovels. This is insane.
Yeah.
Just to tell you a name doesn't exist. So that's where we got to the second piece of innovation that did not break any rules. You see, as we've talked about, the difference between the name doesn't exist and the query type you're asking for doesn't exist is almost semantics. The answer's still no. But the more specific one, you asked for this name and this query type. Well, unfortunately, bud, that query type doesn't exist. Not telling you if the name exists or not. That query type definitely does not. Why do I prefer that kind of odd answer? Well, it's a whole lot smaller.
It's smaller to answer that way than the previous way.
Right. There's no such thing as a wildcard record or anything. I just simply say the query resource record types associated with label are all of the following except the one you asked for. All of them except the one you asked for.
Just hang on a moment. The first one that involved sending the SOA and the RRSIGs and the NSEC and all of that authoritatively said that thing you asked can't exist and here's the proof why it can't exist. And this one is not giving the authoritative proof in between two labels, chain, zone, SOA. It's saying that label, that type doesn't exist.
It says a little more than that, which is kind of pushing the truth, because what it says is the other types that I'm going to provide you in this answer might or might not exist, but the type you're after is not here.
Right.
Signed by the zone key.
And by saying might exist, it gets around the problem of having to authenticated deny the entire label. It's just denying the type you asked for. That type, no such type. Here are 6 other types that could exist. Signed me.
And if you provide that kind of response, everyone believes you. So if you provide a response that says, here's all the types that exist, but the type you're after, and let's say it's an A record, is not there,
right,
then your real answer is that name might exist, but there's no IPv4 address, which is what happened to Slack.
Right. The way a good actor's working, it's just been told there is no A record. It immediately drops in the code path to say, we'll ask for a quad A, and you try that, and the quad A says, there's no quad A, but there might be these 6 other label types, but you're a good actor and you go, no A, no quad A, sorry, can't connect, you're gone. If you were a bad actor enumerating, you might go, I shall ask for the Hinfo, the TXT, and the PTR record because you said they exist. And the minute I ask for them, Geoff, I think I know what you're going to do. You're going to say, nah, they don't exist.
No promises, bud. All that's in there are records that might exist, but if you ask for them, I will give you a signed answer that says it's not here. Others might be here.
But good actors probably never come back and ask.
So ask away, but, it's basically saying it's not here, and it's a really small answer. because now I've got a single NSEC record and a single signature. I can even get a DNSSEC answer under 512 bytes now, particularly if I'm using elliptical curve.
So you are being a little mischievous in the answer, because you don't absolutely say don't come back. You treat each request as an absolutely atomic thing, and on the wire send well-formed packets that say nah, but you do it in a way that implies something. But you know what? I'm not sure that matters. I don't think that matters.
The RFCs were totally vague, and oddly enough, this approach broke nothing. It's very clever.
Extremely clever.
It broke nothing. Extremely clever. And indeed, now we get on to the next chapter in this story. It was so clever that other folk wanted to do it. Fine, so clever that some folk took it back to the DNS Operations Working Group of the IETF and said, we need to standardize this. We need to make it into a specification because it's just too good not to, right? And so work has been going on. Now, we've gone through a bit of terminology change over the period, and we're certainly becoming more sensitive to the use of various words. So what used to be called white lies, here's a minimally spanning NSEC record, and black lies, here is an NSEC record that says, the name might exist and these record types might exist, but not the one you asked for. It was a black lie. It's a bit pejorative. So we now talk about things around compact denial of existence. And that's a fine thing to call it. Bit of a mouthful, but, there we are.
Yeah.
And so up has come a draft, and it's getting close to being standardized, called compact denial of existence.
This should be fairly straightforward. Take the thing they do, document exactly how it behaves, put a frontispiece on it to claim copyright to the IETF, publish, done.
Well, no, at this point, George, my jaw is bouncing off the floor. It's kind of, hang on a second. The reason why folk went this way is that they weren't the IETF. They could not change the DNS.
Right.
They were sitting inside a sort of an environment that had these RFCs surrounding them. And the real challenge was chart a path. See if you can get your way through these obstacles.
Yeah.
And you're not allowed to change behaviours that are specified in the RFC. But along comes the IETF and says, well, we'll get involved. And you know what the answer really is if you've got a front-end signer? I'm going to tell you that the name you asked for does not exist, signed by me. Full stop.
They went the other way. They went to change the protocol and made a record that says does not exist.
Yes, because, they actually invented a synthetic record called NX name, which is even more bizarre. But they kind of missed the obvious. It's not a case of doing a minimally spanning NSEC record. It's not a case of doing every query type except the one you asked for does not exist. They were just workarounds. If you've got a front-end signer, and if you're allowed to change the semantics of, the actual DNS spec, then you asked for this name and this query type. Now, I can either say that query type doesn't exist, signed by me, or I can say that name and that query type as a pair does not exist, whatever, signed by me. I don't need to play silly games.
And I can absolutely say does not exist. It's now a known type of response that comes back, which allows the resolver to say to the client, don't bother searching, this doesn't exist.
Now, I can only do it if I have a front-end signer. And if you're not using front-end signers, NSEC, NSEC 3, press on with what you're doing. Compact denial existence, that's a trick used by front-end. But if you've got a front-end signer, you actually don't need to play the game if you're the IETF. You can just say, here's a new resource code, an R code, a response code that says, nope, just no, signed by me. Because now I know what you asked for. I've got a key. Here's the right answer.
But you do have to modify the entire population of resolvers and clients to be aware of this new code.
Well, that's the whole issue of the IETF and change control. At some point, you can declare a protocol dead and buried. Cannot change it. It's in cement. Too many folk won't change. We're stuck with it. And it's sort of, oh, God. But oddly enough, even things like the DNS, which you'd think are so widely implemented that they're stuck, aren't stuck. We've been talking for some years about this whole issue of empty non-terminal names.
I think that's one for another ping talk, Geoff. We don't have time to talk about
It's a big one. But, we invented a new response for that kind of situation. We've invented a new resource record code called the HTTPS response.
Yeah, so it's heavyweight pushing rocks uphill, but if you really need to change the DNS, we are still prepared to change it. But it's very interesting that Cloudflare found a way to achieve a scale outcome with no changes for anyone using a trick that technically tells a little bit of information, but it just worked. But when you open the door to say, let's do this in standards, where you arrive at is, no, we're not doing that. We're going to have a record that says it doesn't exist.
They are doing that. They're making a standard for the hack. And I'm sitting there going, but you don't have to. You have the pen. You can change the spec.
Wait, so they're standardizing the mechanism to standardize the hack?
Yes, compact denial of existence is in its final stages of becoming an RFC. The hack is being standardized. And you kind of go, well, there's a couple of questions I have. Nothing changes. Nothing. Why are we standardizing nothing? You could do it anyway, dude. People do already,
Yeah.
What's the standard? What does it mean? I don't know. I've got a front-end signer. I can do that. You always could. Didn't need an RFC to say you always could. But if you do have the pen of change, OIETF, then stop doing hacks.
Yeah.
Go straight to the nub of the problem and go, you know that name you asked for?
Not there.
The answer's no, not there. Sign me, because I've got the key. Sign me. Goodbye.
Finding a way to say no quickly is an odd place to be, Geoff, but it seems to me there's a call to efficiency here that says either don't document and hack or find a quick way to say no, don't document a hack.
Well, I think there are parties and players, and the privileged part of the IETF is it can change the spec. Cloudflare can't.
Yeah.
VeriSign can't. You've got to get everyone on board. That's the whole idea of standards. But the standards body can change the standard. That's their role. And so sometimes you need to lift your eyes above the parapet. You need to look at the broader landscape and go, well, yes, I understand your hack, and I think it's brilliant. And there's actually no work to do because it's brilliant, but it doesn't change any of the spec. It's just a novel use of it. Great. Tell you what, you're trying to solve an underlying problem. Let's cut to the chase. If I've got a front-end signer, I can sign no for every question, giving you the answer back as part of the question. I can customize the answer to go, you asked for foo, foo's not here. Bye. Signed me.
Missed opportunity?
Oh, you can always do it later. I don't think it's missed yet. But it just struck me as odd that a lot of energy is being spent trying to do work that I actually think in the standards context is non-work. That, realize your awesome power as the holder of the pen of standards and use it wisely. Use it wisely, of course, but don't be afraid to use it, because otherwise we are stuck.
And the answer is no.
No.
Oh, thanks, Geoff. That's been absolutely fascinating. What a story to bring back from DNS OARC.
Indeed. And hopefully the next meeting will be even more fun. Who knows?
Cheers.
Thank you.
Next time on Ping, we're hearing from the recent PIMF meeting, the Pulse Internet Measurement Forum, that was held at the Apricot meeting in Petaling Jaya. If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember, the Measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time.